Yeah, there's a cosine rule coming. So to work out which rule that we use, it's all about writing your stuff down and reading the question. Now for this one, as soon as I read, well, area, I'm straight away going to be thinking of the area formula, right? So I would, if this was me, I actually write A equals 150 centimetres squared. I'll write area equals a half AB sine C. I am not going to label my triangle because I pretty much can see that I've got my 2 lengths angle in the middle. Huzzah? The only difference with this question is when I now substitute my information in, I'm not going to just go, oh, equals. I actually know what the area is. So I pop in 150. Everything is underneath, nice and neat. Times A times B. You can say times 14 times x, you can say times x times 14, whatever. And then sine 78. You want to get x by itself. It's being times by 14. How do you get rid of a times 14? It's being divide. They said that. Very good. How do you get rid of a times a half? Divide. How do you get rid of times sine 78? Divide. So we just put everything. We go, we're going to get rid of all this times, and we're going to divide the other side by that. Okay? So it's a half. And you might go, hang on, you're writing a times there when you said divide, but it's all underneath the fraction, and so that is all dividing by. And remember, before you go on and boom, 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 your calculator, if you're borrowing a school calculator, if you've lent your calculator to somebody else, what do you need to check? Right, that you're in degrees. Excellent. So can everyone have a go? What do we get? If this was an assignment, I mean, obviously this is a book question, so you would check your answer. You don't just go willy-nilly on to the next. Make sure that you've checked your answer. If it was an assignment or a test and you want to check your answer, Ella, what would you do? Right, sub it back in. So go a half times the 14 times the 21.91 times sine of the angle, and if you don't get 150, then you have made a bit of a whoopsie. Now, obviously, we've rounded off, so we might get like 150.0 something, or we might get 149 point. That's close enough for us. I mean, remember, we are doing the whole exercise of area, but I'm wanting you to think about if they're all mixed questions. Yes, we've got area. Find the length of the equal sides. Do we know what the equal sides are? What shall we call it? Now, we don't want to call it A and B because then, no, don't be sorry, but that's then making them different. So if we call them X, now we've only got one unknown, which means we can probably solve it. So once again, because it's given me the area, I am writing down area equals a half AB sine C, and then I'm going to slap in my information. I know the area is 80. It says equals, I put equals a half. What's my A in this case? Great point for making certain that your timeses look different to your X's. Okay. Times sine 112, and remember sine of 112, that's just a number. It's a big old decimal number, but it's still just a number. So we're going to tidy that up. A half, what is x times x? X squared. Now I can also write this in any way that I wanted. I could write it's a half times sine 112 times x squared. Eden might have gone, I don't like this half out the front, so she could get rid of it by timesing the other side by 2. I can't be bothered. I just do it all in my calculator in one move. Okay? So, technically, and wait to see what I do, and you can decide how you want to write it. To get my x squared by itself, once again, to get rid of all the times, I have to divide. So just wait before you write. So I'm going to go x squared equals, and we have to divide the other side by all of that. And I go, oh, am I going to write that all again? Because I don't want x squared. I just want x. So how do I get rid of the squared? So I'm being a little bit naughty and I can go square root. I saw the faces. They didn't like that. So if you wanted to, another little shortcut that I can do, I mean, by all means, write it again if you want and say x equals the square root of, or I can just go square root of a little bit sneaky. Yeah, we can do that. I won't deduct marks. I mean, so you're adding this to your formula page. Sine rule, same, right? And why is it that you can flip fractions? I hope we all know that. So if I've got 10 over 5, which equals, cancels to 2 over 1, do we agree? If I was to flip that, 5 over 10, that's the same, flip, 1 over 2. That's all we've done here. So it's really the one rule. We've just flipped it. Agreed? You could see in your textbook or in other textbooks, they might add another one that says equals C over sine C. Correct. But you don't need all three. You just need 2 of them there. So we use this one when we're trying to find a length, because the idea is to keep your life simple. It's always best to have your unknown upstairs. Okay, so we use this when we're finding a length. And this one is easier to use if we're finding an angle. Now, it's not disaster if you use the wrong one. All you're going to have to do is do one extra step and then flip it. You'll see what I mean in a minute. And as you're writing this down, I shouldn't be speaking as you're writing, but I'm going to. When we talked about, Ross and Monica, in the area rule, where we had 2 lengths and the angle in the middle, with this one, we are talking about, we've got the angle and its opposite length, and then this angle and its opposite length. So we are talking about pairs. Pairs. So you must have pairs of angle and its opposite length, and then one other one to use this rule. Okay, so here we go. We look. First thing, remember we said about their mixed questions. How do you know if it's going to be area, cosine rule, or sine rule? Since we haven't done the cosine rule yet, we can rule that out. But obviously the question, no area is mentioned, so we're not going to use our area formula. Agreed? It's non-right angle, so we're not going to look at our right angle trig. And the first thing we notice, or that I notice when I'm looking at this, is there is a distinct, I've got an angle and I've got its opposite length. I've got the length that I want to find, and once again, I have its opposite angle. So here we go, straight into our formula. Yeah, I have to force myself to write the formula, but yeah, better had. Be a good mathematician. Be good, be good. Now, I've chosen to go A over sine A and not sine A over A because, again, I'm trying to find a length. So keep my unknown upstairs. Do I care again which one's A, B, C? No. I'm going to put my unknown here, so it's x over sine of its opposite. Yep, that's simple. Equals 15, as long as you don't go sine 46 over 15. You can't stuff up, right? It's got to be 15 over sine 46. And you're going, I don't know about this. It's too simple. I am suspicious. I don't want x over sine 32. I just want x. So how am I going to get x by itself? Yep. So all in my calculator, using my calculator once, sine over 46 times sine 32. Huzzah! We're done here. And C, because you want to do every single question, good. If you just did C, I'll be okay with that. When we come over to question 2, What are they trying to make sure that you're aware of in question 2? Look carefully. Mystery student.
Huh?
What do you say?
You don't have the angle and the
But I have 2 angles there. What do you mean I don't have an angle? It's not. He's giving me directions with his hand. He's going with that, like opposite. You just have to say opposite. Very good. We do not have. We've got a pair here, but we do not have this one. So you cannot be a slacker and just go, oh yeah, x over sine 83. No. It's got to be opposite. Blake, hit it. What do you have to do? Yes. Yes, there's 180 degrees in a triangle. Subtract. Yes. So be aware of that. All right? So could I ask you to cruise through 1, 2, 3? Okay. While you're doing that, I will also come around and check people if they've got questions from the right angle. All right? 2 of the sine rule. And it goes like this. So part 1 was we were finding an unknown length. Part 2, as you can see, we are finding an unknown angle. Hey boys. Once again, we're looking and we can see, oh, we got pairs up. So because we can see pairs, once again, we're going with the sine rule. And the only difference is this time, instead of saying A over sine A, we're starting with sine A on top because my unknown this time is an angle. Can we live with that? So we carry on and we go, okay, sine theta over its opposite length. I mean, that's the only thing you got to look for. Opposite equals sine 63 over. Correct. Well done. Didn't say 6. All good? Blakey boy, sine theta, divide by 6. I don't want that divide by 6. How am I going to get rid of it? Times by 6. Fantastic. Some of you might then leave this line out, but it's up to you again. So we times by 6. Remember, not touching my calculator. And all I have to do now, I don't want sine theta. I just want theta. So how do I get rid of the sine? Not divide. What do we call it? I know what you mean. Inverse sine. Correct. So we will go theta sine to the minus 1 and we just, you can either type in what you see. Do any of you use the answer key on your calculator? So your answer key, you can actually just type this in and then you go shift sign of the answer. It doesn't matter, it's just whatever you're used to, right? So you can type in what you see or just type in what's in the bracket and then shift sign of the answer. Your call. Now, there is a little part 2 to this, which I'll get you to look at, or I'll talk about in another 5. All right, it's just a little check stop. So you can start going ahead and doing these ones as well, and then we'll go back and we check, because sometimes these could have 2 solutions. Okay, so everyone was happy, I hope. Some of you might not have practiced at the minute, but you know, if you can do the sine rule, finding the length, finding the angle, it's not that big of a deal. So once again, if we look at example B, yes, we've got our opposites, we've got pairs. So we're going the sine rule. Because we notice we're finding an angle, we start by going sine theta over 17 equals sine 23 over 8. Are we good with that? We go easy. We say, yeah. To get rid of the divide by 17, we times. That gives you sine theta, and to get rid of the sine, we inverse. Girls watching here? We inverse. We get this. All is well, but we check what the book had, and they had 123. Seriously? We got 56. What's going on there? This is the bit that you have to just double check when you're using the sine rule to find an angle. Look what I am doing here, please. If I was to extend that line, and instead of having this 8 flick in, what if I flicked it out? Oops. What's happening? Yep. What if I flicked it out there? That's 8, that's 8. This is still 17 degrees. This is still 23 degrees. So I can draw two triangles with the same measurements that I was given. I can draw two different triangles. Does everyone see that? Still 23, still 17, that's 8, that's 8. So instead of flicking that length in, I flick it out. So when you have, and you're finding the angle using the sine rule, you just have to check, and we call this checking for the ambiguous case. Great word, ambiguous. Now you might be going, sigh, oh my God, do we have to do another thing? It's not that big a deal. This is all you do to check for the ambiguous case. And you could just do it on your calculator. You go 180, take the answer that you just discovered, which is 56.13. And we get an answer of 123 point. Thanks. Should have done that, man. Please listen. So you find an angle using the sine rule. You get an angle, you go 180, take that angle, you look at this, and now you have to check. 123 plus 23, is that less than 180? Correct. Well, that means we could have two solutions. So it could be 56 or it could be 123.87. Make it sense? When we did this one, what was the answer that we got? I'll just go back and cheat. 41.9. 41.9. If I do this, I say 180, take 41.9, we get 138.1. So we check. 138.1, check it, add on to our angle here. What's 138 plus 63? I don't even have to work out what it is. I already know. That's more than 180. Agreed? Mm-hmm. So in this case, there are not two solutions. It's just the one. In the example, they're then saying, oh, because it's clearly obtuse. Do you remember acute angle is less than 90 degrees? Matt, come on. Acute is less than 90 degrees. So if you look at this one, this triangle out there, that one would be the acute angle. But one of the big things in maths is that you should never assume a diagram is drawn to scale. So if this was me doing the question, Kylan, I would give both solutions. If the question said the angle is obtuse, then I would write this one and ignore that one. If it says the angle must be acute, then I'm going with this one and I'm not touching that one. Yeah, because I can draw that triangle with the same measurements two different ways. While I have you here, and sorry people on the video, you won't be able to see this,